Welcome to the Berlin 2018. This is our first meetup in the 2018. And I'm really happy to see a lot of you here. It's a record. Thank you for coming. The Wi-Fi password is there. I hope you already connected. So Elixir Berlin Group Meetup is started since 2013, and it thanks to you. Give yourself a round of applause, please. Now we are keep growing. That's really good. Good for Elixir and also for somehow for job opportunity, because it looks like there's a lot of companies interested in Elixir. That's good. So we can keep doing what we like to do. And also you can find us in different platforms. The main platform that you find us probably is meetup.com. It's the place that you RSVP the meeting. There is I printed the name of the attendees here and there. If you like, if you don't mind, you can go and tick your name there. The reason is it's getting really unreliable. It's hard to predict how many people are coming to the meetup. It's also making it much harder for us to arrange the food, arrange the plate, and everything. So we're trying to see who is coming more often, and then we know that these are the common people, and some of them are spammers. They never show up, so we make sure that contact them. Or we can do something like this about it. We have a GitHub account, GitHub organization that we plan the meetup, the presentation. So if you have anything you want to present, just go to Elixir, github.com, Elixir-Berlin, planning repository. You can create an issue. You say, I want to talk about something in the coming weeks, or our company wants to host the event. You can put it there, and then we will reply. That's open, nothing. And also we have a Twitter account, Facebook, Slack, IRC, Google Plus. Who's using Google Plus there?
Follow Google employee?
It's there. It's the more important thing is if people go there, there's a community around it. It will evolve. Google Plus. Otherwise, it would be an empty group with only one person. I also want to give a big shout out to LittleAlchemist. Sorry. For the place, for the food, for the drink, and for the present, for the speakers will get the presentation from this company. Do you have anything to share?
Sure. Like, if you lend me your ears for like 2 minutes. Hi, I'm Florian. I'm the lead architect, hence the title, since last December. I'm really proud of that. Welcome to Klöckner.io. The I stands for
innovation.
Thank you. Innovation. We're a steel company, and at this point, I usually go into a 2-hour, 3-hour rant, like how great steel is. I've decided for this presentation to go with the short version. It's great. Thank you. If you want to know more about what Klöckner.io does, what we specifically do, how we adopt Elixir, for example, and other technologies that might be interesting to you, please don't hesitate. Approach me, approach my developers who are here tonight. Enjoy all of the presentations. Enjoy the free food. There's beer. Please enjoy the food. We ordered a lot of it. It's really good as well. I already tried it. And yeah, most important of all, have fun. Thanks.
Language. Okay. We have 3 talks today by Neil, by Nick, and Frank. Yes. We'll go to each one of them by this order. Give them a round of applause to start.
Okay, you have to bear with me tonight because my speaker notes are on my phone because we got this weird setup, so I will probably forget half of my presentation. Okay, thanks for having me. It's nice to be on the other side of the presentation for Elixir Berlin for a change. I'd like to talk about API versioning. So API versioning is hard. This isn't going to change that, but I'd like to share some learnings we've had over the last few months on trying to improve it for us. So my name is Niall Berkeley. I'm a software developer here in Berlin, working for Meltwater. Meltwater are a media intelligence company, storing and analyzing a lot of data to improve and help people gain insights on their products and their companies and their competitors. For the last year or so, we've been working on the Meltwater API. This is a client-facing API to help clients get the data from Meltwater and integrate it into their own product, or into third-party reporting tools, but basically integrate with a platform that's going to be an app that they would go to. They use the API to integrate with it into their own tools. So it's a new product, and we built it kind of from the ground up. We built it with agile methodology. So we plan, we build, we test. We had iterations. We made changes based on customer feedback. We didn't know what we were going to build at the start, so we tried to iterate on the product and figure it out with feedback from the users. But the thing is, we're building an API. This isn't a web page where you can just add parts and remove parts and change things around. You're building an API, and an API is a contract. It's something that you are defining and telling people they can depend on, something that they can build against and that they can support, or that they can expect that it won't change. And if you change that API, then you're breaking the contract. You're basically going back on your word. You're saying that the things that people can depend on, they can't depend on. And their integrations are going to break. They're not going to be happy. So how do you fix that? You introduce versioning. You create multiple versions of the same endpoint, or multiple versions of your API. But this means you also have to support multiple versions. So the complex business logic that you have to get your data to your users is now more complicated because you have different versions, you have different logic for those different versions. It definitely adds a lot of overhead. Because this is complicated, we try to avoid doing this too often. So we say, all right, we'll wait till there's enough features or enough feature requests, and we will cut a new version in 6 months or next year. So then the upgrade path for these new versions is usually pretty high. So people tend to avoid upgrading because there's so much things to change. So we tried to look at an alternative. When we were building this API, I said we built it as a beta. We had a lot of changes based on a lot of feedback, but that wasn't really scalable. We can't just keep changing the API. We tried to look at what would be a better versioning strategy, what would be better for clients and what would be better for us. So starting off looking at the client, some things that would do it better for them. The first thing would be a stable API, an API that doesn't change, an API that's stable, that they can depend on, that they can build things against. I think, actually, going back to that, I think you remember last year, Instagram changed their API. They removed access to user feeds, which broke like a whole slew of apps. Like you don't want that to happen in your API. Documentation. Documentation is obviously a very important part of APIs. If there's multiple versions of the API, then there's going to be multiple versions of the documentation. It kind of sucks when you are looking at the documentation, you make a change and you realize it doesn't work because you're running on a different version to the documentation that you're looking at. It would be nice if the documentation you're looking at is the documentation for the version that you're running. Obviously, an API should be easy to upgrade. If you are changing versions, it would be nice if you don't have this slew of changes from 6 months of development or a year of feature requests that you have to integrate all those changes. It would be nicer if you have just 1 or 2 features that you can upgrade piecemeal. Some users don't care about versioning. Some people just build their integration. It's running, it's fine, they don't care. Sometimes it's a third-party team who are building the integration for the company, or it's a business user who's setting up a report. They don't care about versioning. So sometimes users don't really want to deal with it. But obviously, we shouldn't just be taking user requests into our mind. We should think about what works for us as well. And for us, having like an agile methodology and trying to release features quickly and iterate on these things, it's nice when the API is easy to change. We can add new features work on new stories, and push things out as we go. It's also helpful when the API is easy to maintain. If we have multiple versions and there's branches and different logic for all those different versions, that will become a nightmare because we basically have to maintain all this different logic. It also helps when there's an incentive for users to upgrade. So if upgrading is difficult, and if upgrading is going to break their application, then people are not going to want to upgrade. If we can make it easy and push out features to show that upgrading is worthwhile, then hopefully they'll have an incentive to upgrade, and it'll improve the process. So taking all those things into account, for us, we need to release loads of versions so that we can have this agile release process and keep pushing out features. But at the same time, we want to support a stable API, so then we need to support all those new versions. So that kind of sounds like a terrible idea, like supporting everything and maintaining everything. But it doesn't have to be so bad. There's a really good blog post from Stripe, the API payment gateway, on how they deal with versioning. So they actually support multiple versions. They have like rolling point-in-time versions that are named after the date that they're released on. And these versions are actually layers that the requests and responses go through to get to the correct version. So we can take a look at how that works. Let's say we've got a user, we've got an API gateway. So this gateway could be part of your application, could still be part of the API, just it intercepts requests before they get to the API. We've got a version store, and we've got the API itself. So we get a request for the user's very first API call. So it comes in, they've got their API key, it identifies the user. We look up the version for that user. In this case, the user's first call, so they don't have a version. So then we actually set the version. So this version would probably be the latest version that we're running at this time. And then we pass the request through to the API for that version. And then that returns that. So then the API knows that the request is going to be in this format and the response should be in that format for that version. For an existing user, this time they make a request, again with an API key. We look up their version. This time we know it because we've tagged them with it the first time. And we pass on the requests, get their documents, return the response, it's all good. If a user wants to try a different version, let's say we've got, they want to look at upgrading, or they want to try an old version and compare it, this time they can actually specify the version themselves. So they could use a new version or an old version, pass it through. We don't even need to look it up this time. We get our documents, and the user gets the documents in the version that they want. Okay, that's pretty straightforward. How are we actually building this? So the main thing that we're doing is we're keeping the core of the application current. So our application is always running on the latest version. Our application is only running on one version. And then we actually release rolling versions. So all these new features that we push out are actually new versions. Again, the application itself is going to be on the latest version, but we have these rolling date-based versions. And these versions are transformations. So we start at the latest, and then we step back through each version to actually transform the data from version to version to version. Okay, so let's take a look. We have a user at version 6, and they are going to make a request. This comes in as version 6. It's gone through our API gateway. We've identified that user as being on version 6. We then transform the request from version 6 to version 7. It goes into the application. Version 7 is the latest version, so the application accepts it, does its thing, returns the response in the latest version, and then it transforms that response back to version 6 and sends it back to the user in their version. How are we implementing this? So we are using Elixir, the functional programming language. It's something that is very good at transforming data. Like data transformations, they take something in, they give something out. It's a nice diagram for Elixir. We are using Phoenix for the framework backing some of our APIs. And that actually has a really nice methodology of just transforming a connection as it goes through the application. So a connection comes in, goes into the endpoint, goes through to the router, through a pipeline, through a controller, into our application. And that's exactly like a good example of the data transformation of a connection. And because Phoenix comes with plug, the plug library, which is a simple library that just takes in a connection, gives out a connection, and transforms it on the way through. We can actually slip plugs into this pipeline. And we can use those plugs to add things like authentication or versioning. So we can take a look at a simple sample application. It's just a to-do application. It lists a bunch of to-do items in JSON. We have get requests that returns two to-do items, and it specifies a size parameter of 2. And then this is the response. This is just a simple API. But let's say we want to change the size parameter to page size. So it's a simple change, but it's a breaking change. If we don't tell our users about this, then their pagination in their application or their integration is going to break. So here we have a user in an old version. They specify a request in the old format. So there's passing this old parameter name size. We transform that parameter name from size to page size, the new version, and send that into the application. But to implement this, we can just use a simple plug. So all this is doing is pattern matching on the connection on the way in, and it says, okay, there's the old parameter size. All it does is swap that out and put in page size and pass on the connection. And if this doesn't match, if that parameter is not there, it just passes through the connection. Works as normal. Let's say we need to change something in the response. We have the to-do items which have a title, an ID, and a description. We want to change the description to details. Again, this is a breaking change. People are expecting the field to be description. This time we have our application running on the latest version with our latest format, which has details. And we transform that response from details to description. So similar to what we did with the request, but with the response this time. And then we pass it back to the user in the format they were expecting. So again, we can use a plug to transform the response. This time we have a helper method called transform description, but the important thing to note here is this register before send. So this is basically going to register a callback to be applied to the connection just before it's sent back to the user. So the request comes in, it does a thing in our application, and before we send it back to the user, we actually run these callbacks that we register here. And the transform description is a simple method that just swaps out. It actually decodes the body, swaps out the parameter from description to detail, and returns it. And in this case, because it's just JSON, we can actually just even use a regex and pull out description and swap it. It's just a string. So just to recap on the overall flow of how this all works, we have a user running the old version. They send a request in the old format, it's transformed to the new format, goes into the application, which is running the latest version, returns a response to the latest version, transformed to their version, and sent back to the user. And rather than creating a plug for every one of these changes, we can create a behavior to model a change. So the behavior represents one change to the API. It could be updating a field, or it could be removing a field. And it has two methods, just transform requests and transform response. Then we can actually gather up those changes in versions. And these versions are represented by dates. Dates actually work really well because you can actually sort them so that you can make sure you're applying your latest versions in order. So you start with the latest version and step back through the older versions to get to the version that you want. So then when we actually want to get a request or response to the correct version, we basically take in the version, find all the requests that find all the changes that are applicable to that version, and basically apply them. And we can do that again using a plug. So rather than having a plug that actually makes every change, we have one plug that takes all the changes and applies them all. So basically our plug will find out what version we're using, it'll get the changes for that version, apply those request changes, apply the response changes. So this is an example of how it would look. We're taking in a version as a header, and we're getting the collection of changes that apply to that. Then we are applying all the request changes, and then applying all the response changes, basically registering callbacks to apply all those. And because all the changes are ordered, they should be applied in the correct manner. So all that is, we saw how easy it is to do. It's even easier because there's actually a library that does all this for you if you want. Multiverse is it's a really nice library for implementing a lot of this. It defines behaviors and applies all your response and request changes. It's nicely written, it's well tested, and it was actually a good inspiration for how we're doing this and even this talk itself. So to recap, based on the criteria we were trying to achieve at the start, we wanted to get a stable API. With this versioning strategy, because stepping back through versions is nice and simple, we can afford to maintain those older versions. So rather than saying, okay, we're going to upgrade and deprecate the old version, we can actually maintain all these old versions because the older versions are just simple transformations of data. The documentation actually works pretty well for us because we're using Swagger to document our APIs. So when we cut a new version, we just actually create a new version of the Swagger JSON. When a user is logged into our developer portal, we know what version they're on. So we actually serve them the correct Swagger for their version. So everything that they're looking at is correct for their point in time. Obviously, they can select a different version and see different documentation, but by default, they see the documentation for the version they're running on. Users who don't care about versioning don't need to think about versioning. We actually maintain all the versioning for them, so they can pass the version as a header, or they don't even need to pass it as a header. Once we have their API key, we can look up their version and find out what version they're using. It's much easier to upgrade because all these changes are much smaller. All they need to do to step from one version to another is actually make whatever change that transformation is. It's pretty straightforward. And for us, this definitely makes our API easier to change. We can push out new features and push out new versions rather than having to wait 6 months or a year before we can actually cut a new version of the API. It definitely keeps the code a lot more manageable because we're always running on the latest version. Rather than having ifs and branches based on the version and the different logic for the different versions, we're always running the latest version, and the transformations are isolated and they can be tested separately. All they need to do is test the data chain from one state to another. Definitely is a lot easier to deal with. And obviously users should have an incentive to upgrade because this process is a lot more straightforward, smaller changes, and hopefully they are attracted by the newer features coming out. So if this is so great, why isn't everybody doing this? I mean, from what I've seen, there's probably a handful of people using this versioning strategy. The thing is, versioning is hard, and instead of users dealing with the pain of versioning and upgrading, we're dealing with it instead. I mean, it definitely adds an overhead because we have to integrate versioning into our entire application. It's like the first-class citizen of our API. Testing can be harder. While these transformations are easy to test in isolation, we have smoke tests that actually test like a request and a response. And to test multiple versions, we need multiple versions of those smoke tests. So overall, it's a strategy that we're really happy with. The thing is, it's a strategy that while we can make loads of changes, we still try not to. The most important thing about this is designing an API correctly, making the right decisions, and not just releasing loads of versions because you can release loads of versions. The other thing to be aware of is your users. Are they technical users who can upgrade? Are they users who don't want to upgrade, who you need to support and help them not think about versioning? So, I mean, you have to think about the right tool for the right approach for the right users. And for us, this actually works really well, and this is the right approach. So, yeah, one other thing that we did look into was GraphQL. We did actually have a version of our API running GraphQL, but some of our users thought REST was bleeding edge, and they just wanted a SOAP API, so GraphQL was like a million miles away from that. Yep, that's pretty much it. Thanks very much. I've got a few colleagues here from our company as well. We've been using Elixir for a while at this stage. We're using pretty extensively. I'm sure that I'll be happy to talk to you about it. We also have a blog, underthehood.littlealchemist.io, where we talk about what we've been working on. So yeah, feel free to talk to us any of us after. But do we have any questions?
So you mentioned that you try to provide an incentive for users to upgrade by, like, that's how I get access to your features. But that also I can just kind of, if I don't care about versions at all. Do you have any strategy around like migrating users who aren't actually upgrading their versions so that you're not having to support all old versions forever?
Yeah, like, so this is still quite new. We haven't had to do it yet. Ideally, we won't have to. But the idea is that we have kind of agreed that we will support all versions. So technically, users won't have to upgrade. Stripe, the company who kind of did this first, still support versions from 7 years ago. So they still support every single version that they ever had because it's a manageable way of doing it. And that's kind of the idea, is that it's a big commitment, but it's hopefully manageable. Yeah.
So like roughly how many different versions do you have now?
We have, I think, 4, so not that many.
So I don't know, I guess when you get like into the hundreds at one point, or do like daily releases or whatever, then it might pile up and make the requests and responses slower.
Absolutely. I mean, if you were transforming a request 100 times, then it's going to slow down. But if you are transforming 100 requests 100 times, then you probably need to look at how you're designing your API if you're changing it 100 times. Yeah.
In the example that you showed with the to-do app, which was really clear, by the way, thanks for that clear presentation. So a lot of the changes were quite like trivial, right? Like name a field and so on. Have you had any changes where it's not so simple to just do a simple transformation, where you might need access to information that's no longer coming in the new response, for example?
Yeah. So there are definitely times when there's things like that. We actually don't even have a database, but I can imagine if you change the field in a database, it would be a problem. We have an underlying library that we actually use, and we are passing a version into that library, but that library is actually using a versioning strategy itself. And there's things like that, when you've got dependencies, you need to manage your dependencies versions and things like that. For things like removing a field, let's say you want to get rid of a field because of like copyright laws or something like that, but you're exposing a field that you shouldn't have been exposing, you could at least nullify that field in the old versions and still provide it so that it won't break the integrations and the new versions can remove it. So there's benefits to this as well for kind of conflicts, things like that.
In case this transformation pipeline is piling up, like this guy said, did you research for some super smart caching technology for this, or is it possible because the requests are always?
We basically haven't addressed the performance because there's not been an issue yet. I mean, I think there's definitely ways that we could. I mean, some of these things are actually decoding the JSON, re-encoding the JSON, and that's obviously not efficient if we're doing that 100 times. But until we do have a problem, until things are a performance problem, then we're not going to look at it yet.
The nice thing is that you can also then probably make analytics on which API versions are actually used and then like squash them.
Yeah, and we are like keeping track using Grafana of every call that's made and what version it's made. And while we have agreed to support older versions, you could technically maybe, if you see one version is no longer being used by anybody, maybe you could deprecate that. Anybody else? Good. Thank you very much. I was admiring these. Thanks.
Guys and gals, sorry. One small thing, if you have like an empty bottle, like this one, there is like containers for it. Just put it back. It will help us tremendously in cleaning up afterwards.
Thanks. Put this thing in. For the change? Yeah, no, the text is up there. Okay.
Should we start? Yes. So, hello, my name is Frank. I'm a freelance developer in Berlin. Last year, I co-founded a company which is called Berlin.ex. We are a B2B platform for the green economy. So actually, I submitted a talk about scaling Phoenix or scaling Elixir, but during research, I got totally distracted. So I prepared something else, and the new title of the talk is Patterns and Best Practices in the Elixir Community. The talk is loosely structured around articles and forum discussions. The goal of this talk is to give an overview about trends and discussions regarding best practices in the community. And I thought it would be a good idea to actually reflect in the talk what I was researching about. So I selected topics based on relevance and if they contain any useful best practices or patterns. So, and also I try to analyze some of the confusions people have with terms like umbrella and microservices and stuff. So let's go. So Phoenix programming Phoenix. Like many other developers, I came to Elixir from working with Ruby on Rails. I guess everybody knows this book. It's a great book. I really enjoyed reading it. The book basically explains a classic model view controller pattern that is very similar to Rails. And of course, all the exciting new stuff like channels and WebSockets and concurrency that everybody was talking about. So, however, somehow the software community introduced the Phoenix framework as a Ruby on Rails alternative. In many articles, Phoenix was directly compared to Rails. I believe that caused quite some confusion. There's a great article by Chris McCord, Phoenix is not Rails. I think most of the people actually read this one. It's from 2015. Chris highlights the distinction between Rails and Phoenix and why Phoenix should not be seen as a web-centric application framework. So what else contributed to this Rails versus Phoenix confusion? I started with Phoenix version 1.2 Well, version 1.2 had different folder structure. That was before Phoenix context. There were two places for the source code, the lit and the web folder. That was quite similar to the Rails structure. It's not working. People seem to be encouraged to structure their projects around Phoenix as a web-centric framework, as they were used to with Rails. Basically, I think that was a weak separation pattern. Luckily, the Phoenix team was very much aware of these pitfalls and made some significant changes in version 1.3. They moved away from the similarities to Rails and encouraged the separation of concerns with the new Phoenix context pattern. So our first best practice could look like this. Single Phoenix application with active dependency, model view, control pattern, use context to decouple, and no umbrella. So umbrellas doesn't mean microservices. Microservice architecture is still a big topic. You can find many articles that directly translate microservices to the umbrella structure in Elixir, Phoenix. There's a great discussion on the Elixir forum about this. And somewhere at the bottom of this thread, someone explains why we should not mix the concept of microservices with the concept of umbrellas. According to the documentation, we differentiate external and internal dependencies. Basically, the umbrella is a way to manage internal dependencies. It allows you to compile, test, and run all applications as units. Nothing more. Of course, there's a great article by Jose Valen that pretty much sums up many of these conceptions. It's also from 2015, and I guess many of you already read it. Basically, he explains why concepts like microservices don't really apply to the Elixir Erlang ecosystem, because Erlang is probably the only language that is explicitly designed for distribution. So our best practice would look like this. Don't think in terms of microservices. Use umbrellas to group projects, project-related applications, or just don't use umbrellas and just define dependencies. The next discussion can be found under the title, Phoenix is not your application. This is the title of a talk by Lance Halvorsen. The talk also generated some discussion in the community. In Elixir, applications can be a stateless collection of modules, or they can implement a supervisor to hold state. Also, applications are meant to be reused in other applications as dependencies, which is quite important from my perspective. In the talk and in this discussion around it, Lance basically emphasizes the same approach that was being done by the Phoenix is not Rails statement before. Lance also has a book coming out. In his book, however, he describes a development strategy where you begin a new project with a business logic without any other layers, no web framework, no database. The goal is to keep the thought process free from any other web-related or database-related stuff. I think this is very useful. So our best practice for this one could be business logic first, separate out into dependencies, build out application layers. As late as possible, this points. The next discussion is about separating the database from Phoenix. Should we separate Ecto from Phoenix? I think today everybody in the community agrees that separating the database is a good idea. So yes, you should. So best practice could be isolate database and application, implement an interface to make it reusable again. Now we come to the last part of the talk and the question, how to structure multiple Phoenix applications. I guess we all agree that the so-called Elixir way, I quoted before, is all about separation, isolation, and decoupling. So how to structure multiple Phoenix apps? Sometimes it is useful to implement multiple applications. For example, to separate the API domain from the public web domain. There are many discussions in the community around this topic. However, like always, the solution depends on the project. Each Phoenix server has its own unique port. So the main question should be how to organize a request pipeline. So to finish off this talk, I want to show multiple solutions for this use case. The first solution could be implement multiple Phoenix servers side by side, like this. That means separate ports, separate endpoints. The benefits of this design are the public server could be exposed on port 80. The private server, for example, the backend, in this case, could be exposed to some other port. The access to the private port could be restricted by the firewall. I actually tried this one. It's, from my experience, not so good, the idea, because the port for the backend is just like an obscurity strategy. So I was always not very comfortable with this. So there's another solution. I think most of you know this demo by Wojtek Mach. He also gave a talk about it. He suggests to implement a separate proxy server to forward requests to each underlying server based on the value of common host. In his demo, he basically implements a barebone cowboy server on top of the request pipeline. However, this design works as long as you don't need to share a session between each Phoenix server, like the web in the back office here. Because the request pipeline goes top to bottom, starting with the master proxy, and the master proxy should not implement any other logic other than the proxy logic. At some point, I had a different use case for a project I was working on. We wanted a single sign-on strategy where the session data was valid between multiple servers. And in Phoenix 1.3, they introduced, so this is the, sorry, I forgot it, that's the best practice for the master proxy solution, you can see. So Phoenix 1.3, they introduced the namespace, the web namespace. The web namespace is used to isolate all web-related code. You can use this strategy to implement multiple web namespaces side by side in a single Phoenix application. And from that, you can create what I call router hierarchy. So the benefits are the default router is on the top of the pipeline, which is the app.web.router. It's a single point of entrance, so you only have to expose one port to the internet. Then we route to the underlying routers based on the value of common host, which we do here. And we can also isolate the API in a self-contained Phoenix server, for example. We still have a single port. We can organize all routes in a transparent way from top to bottom while sharing the session. Sharing the session between here the public and the member, for example. With every new namespace, we add a new and clearly separated domain to our application. So that's it.
There are any questions? So then we take another 10-minute break and continue. Yeah. Thank you.
We could just leave it up here. No. That's a good.
Oh, this one. That's not a joke.
So there were great packages. Oh, sorry. No, I didn't. Basically, yeah, the Alchemist.
No, I mean to make sure that the names
The documentation, so I think if in type age and the method may shows you the dogs. Naturally, you don't need to say. What I'm saying the ID is the model is compiled for it's an or you can tracing, for example, do you use it in console or it has its own benefits. Yes. It's a little bit slow.
You're not able to go to sleep because you have other things you have to do, or you just can't fall asleep.
No, I mean slow in terms of so if you use being with the terminal in the terminal, The kid came cold.
So yeah, Phil is also very close to
Breakfast doesn't generate tags of terminal to
when I was looking for
your speed of navigation is a little bit bad.
and when are you leaving?
The first.
So your left-hand side will take place in nice. So how long have you gone in total? You guys are heading off?
Should I not? I
was thinking like you guys look scarily similar. Oh, you are? Okay, I mean, I could have like you're clearly related. And are you twins, or are you just both rocking the beard, and that's why it looks similar? I see. You're doing pretty well. I mean, coordinate a little better on the clothes, but otherwise you're doing well.
Are you going to share that?
When you say our own, is this like all I'm gonna understand are the insults and just ignore.
You need to change from here. Why are you taking flight? Or just walk? Really hard time. That's the state of it. Yeah, I think because we can next time.
So used to standing out there impressing.
Going past the child.
Yeah, it's good to see you.
Yeah, good to see you.
But what about that meetup you're going to organize?
Yeah, we need to properly, right?
I was about your
Oh yeah. Well, you know, we're leaving our office at the end of the month, so we'll have to make a house cleaning party.
like bring everything before you.
It's not uncommon to bring everything on.
Enjoy your drinks.
Where would I?
I forget what your topic is.
Interoperability. It's here in airline.
Okay.
It's kind of sort of an overview of it, but it gets a little too technical maybe, but we'll see.
you know, the first two talks didn't get super technical,
Yeah.
so you know, some balance.
Balance it out.
Yeah.
You get online spectators.
Yeah, what?
Online spectators.
Oh, wow.
17.
No, oh, no pressure. Don't tell me what the count is at the end.
One's brothers.
Is he his brother or is he just
Sick.
they're not the same height?
No.
So it's connected issues. Like one always beating the other one with a spoon and then eating.
Do you remember his name?
No.
Yeah.
Ask,
Did we sound the horn again?
Yeah, it's not a bad idea.
Maybe they are I think they are coming.
I'm all in favor of the horn.
Oh, yeah. You mean so that you
Oh, Nick, you will get Elixir 3D printer.
Why do you think I'm doing the talk, you know?
Oh, I see.
Yeah.
May I inspect?
Absolutely.
Thank you. Yes.
All right, I guess we're good to go. So this talk is about interoperability in Elixir and Erlang. Beam and Friends. I think I changed the title at some point. My name is Nick Reynolds. I also work here at Littlealchemist.io, and we're trying to digitalize the steel industry. And it has all sorts of interesting challenges, but it's a fun team, and we've been doing Elixir development for the last 6 months. It's been really exciting for me as a developer. Like, I come from a Ruby background, so trying to, experience programming from another perspective is very cool. This is me in a hard hat. So interoperability is sort of this concept of information exchange between programming languages. You have programming language A and programming language B, and you want them to talk. And yeah, for this meetup, it's how your Elixir program talks to the outside world. So there's a lot of example use cases. Math and crypto are like big examples, right? Like, nobody should probably re-implement OpenSSL on their own. Not a good idea. You might introduce new bugs, So it makes a lot of sense to use the existing battle-tested libraries. Parsing is another example. You can use the existing C, JSON, and Markdown parsers. Interfacing with legacy systems. Maybe you have some old programs still in use and you need to talk to them somehow. You have embedded software, where maybe you'll need to talk to devices on a serial interface. And then image magic, right? This will never die. So, and the thing you have to remember, I guess, when you talk about interoperability in Elixir is Elixir interop is Erlang interop. So you kind of have to dive into the depths of Erlang, you know, to see what functionality is available. And this talk is kind of intended to be like a little overview of what you can do, you know, what they've developed in the last 30 years. Like I think Erlang was first released in 1986. So it's been a long time, you know. There's been a lot of C code written, you know, since then. So it's kind of an overview. So, and there's 4 basic strategies. You know, of course, you can like use HTTP and, you know, protobufs, whatever, but I'm going to talk about these 4. They're ports, not like Unix TCP UDP ports. No, these are Erlang ports and Erlang port drivers. NIFs, natively implemented functions. You would implement a function in C and call it from Elixir or Erlang, and C nodes. So I'll first show this little chart. I got this from PotatoSalad.io's blog. He has some really good content. But this will make more sense later because I'll show it again. But basically, this is kind of like an overview. You have these different heuristics: isolation, complexity, latency, and sort of like what the different approaches can deliver you, right? The C node like offers the maximum isolation because it can run on a different host, right? Because, you know, imagine you have an external program running in another process on your host. It can still take down the host if it uses up all the memory or it, you know, uses up all the CPU capacity. So you have to think about these sort of things, and you want to try to optimize for whatever use cases are important to you. I'll first talk about ports. Ports are sort of an interface to an external process. So here I have these diagrams. I'll continue to use these throughout the talk. In Erlang, we have the Erlang VM, also called the beam. And you have the external process over here. And a port is sort of an interface to an external program. And you can talk to the external program by sending and receiving bytes. This can also be strings, you know, in Elixir terms, binaries. And you have this connected process, which is sort of like a handle to the port. And when the connected process dies, the port is closed. And then so you ask, like, so this is a very abstract format, you know, you can send any bytes, receive any bytes, you know, how do you communicate? I think this is a question, you know, that has been asked a lot. And, you know, this is like an example format, you know, what's possible. You could send 1 byte where the first 2 bits identify the procedure, right? And it adds, subtract, multiply, divide. And you have 2 arguments, each 3 bits long. So of course, this is just like an example for very small calculations. But then you could return 1 byte, you know, which would be the integer result. In practice, the Erlang developers have developed this Erl interface, which is sort of a C library, and it's based on this concept from Erlang where you can convert any Erlang term. So an Erlang term would be like a binary or a map or a list, whatever. You can convert this to a binary format. It's similar to if you're from the Ruby environment, you can marshal and unmarshal, or from Python, you can pickle and unpickle. It's a similar idea. It allows you to easily communicate terms, Erlang terms, right? And so this Erl interface, it's available as like a C header file, right? And then you have access to these functions. You can make an integer, right? You can pass a C integer into this Erl make int, and it will then, with the help of Erl encode, encode this in such a way that an Erlang program can then decode this using binary determinant. The same idea has also been implemented for Java, for the JVM. So you have this Java library that also like allows you to encode like the different Erlang types, atoms, binaries, et cetera, character lists. And the cool thing today is people have also worked on some interesting libraries for Clojure, for example, right? So you have this library called Clojang, which allows you to sort of do this from Clojure in a nice way. And this is sort of an example below of like a ping pong, you know, between an Erlang node and a Clojure application running in the JVM. In Elixir, of course, we have the port module. and you can use the open function. You pass it either spawn or spawn executable. Spawn will look for the command within the path. Spawn executable expects a path to an executable. And then we pass here the binary option. You get a port back. Port is like a native Erlang term. And you can also pass this directly to send as the first argument, right? And typically we would pass like a PID to send, but a port also works. And here we're passing then additionally the sender PID, and then sort of the command. And in addition to command and then some sort of binary string, you can also pass close. You can see here we're flushing the mailbox, so we print all of the mailbox entries to stand out. And you can see that when you send hello vent to cat, you get hello vent back. Additionally, there's system command with the array of 3, and this is also port based. This use case is intended for when you want to execute a program and receive output, and then also the status code. But it's not so much intended for like communicating back and forth. Erlang ports have this one problem. A lot of Unix programs, they wait for the end of file signal to output the result. Example of this is cat. You know, if you type just cat on the command line, then you can enter all sorts of content, and you hit Control D, and then you get that back. Sort's another example. But the Erlang ports, they can't receive input after the port is closed, because when the port is closed, both the standard in and the standard out are closed, the input streams and output streams, and you can't get the output. So many of you have probably heard of Porcelain. This is one solution to this problem. You can sort of, it's an interesting idea, I think. You put a middleman in between the Erlang VM, the external program, and then you have, in this case, it's called Goon. It's like a Go executable that sort of fills in the missing like operating system signaling, right? So you can communicate the end of file. So I wanted to give an example. This is how, with Porcelain, you could sort with sort, you know. So this is an example in Bash, right? You can use printf, and you can delimit the letters there. We have BCA with new lines, and then you pipe this to sort, and you should get ABC back. It should sort the lines. And in Porcelain, you can also do this. You can spawn the sort command with no arguments. You can set the input to be received. We'll send it to the process. And you can send the output back to the process that starts this, right? We're attaching send to it. Porcelain process send input, and then we pass the input from the previous command. You can see it's the same thing. And then Porcelain also provides a way to send the end of file signal. In this case, by sending an empty string. You can see once we do this, we receive the output from the PID, data out, ABC, in the correct order. And you also receive a result from Porcelain. Another concept in Erlang is this idea of port drivers. So ports, I mean, they're of course pretty performant, but if you wanted to make it even more performant, you would execute the code inside of the Erlang VM, because then there's no context switching. So you have here still a connected process and still the same port interface as before, but now you have one operating system process, and you're dynamically loading this shared library, and then it's going to be executed. But the interface remains the same. This has advantages and disadvantages. Disadvantage, of course, is if the shared library you know, encounters invalid memory access or crashes in some other way, the whole Erlang VM comes down. We'll revisit that topic later. But I'll go on to NIFs because I think NIFs are an improved version of the port drivers. It's the same idea. You have the shared library, but instead of this sort of awkward port interface, you just have a wrapper module, and then you can access the code from any process. So it appears as a normal Elixir module when it's called from Elixir. This is how a NIF wrapper looks in Elixir. You have, so this example is we have an addition module and add integers with an array of 2. Takes an x and a y and should add them together and return an integer. This onload thing up here signals that like when the module is loaded, this is a hook, it should call load NIFs. which then delegates to Erlang load NIF, and it needs to take a path to the shared lib. In practice, it's probably good to use an absolute path. And then the second argument, in this case it's 0, but if you wanted to upgrade the code at some point, you would want to pass a module version along. And this is how this looks in C. You're including the arrow NIF header file, and then you have access to these macros. Arrow NIF term is any sort of Erlang term. And then you have add integers. It takes an arrow NIF env. This is sort of like a bag where all the Erlang terms are stored. You have the argument count, which is the arity of your function. And you have the argument list. And we can take the arguments out of the list using these other helper functions, enif get int, and then you're telling it to put the contents of the x argument into the variable, into the int variable x. And in the end, we return an integer, the summation of x and y. Down here, we're defining sort of the functions for our NIF module. In this case, just one. It's add integers, arity of 2. And we reference the function descriptor. And down here, this is another macro, which will tie this to the elixir.addition module. We need to prefix it with elixir dot because in the Erlang context, all the elixir modules have this elixir dot prefix. And then we pass the function descriptors. And the other nulls that follow are related to code upgrading and other sorts of things. A makefile for this, you first need to specify the include path. You need to figure out like where are these header files at. So there's this long Erlang invocation that I didn't even copy it all in here, but it's in the actual makefiles. And then you would make a shared library for addition by passing, the right compiler flags. In this case, I'm passing dynamic lib undefined dynamic lookup because I'm running on a Mac, but I've also compiled this on Fedora without any problems by just using other flags. In your mix.ex file, you need to have you need to make an addition to the compilers because you also want your C source directory to be compiled when your mix project is compiled. There's a great project called Elixir Make. It's under the Elixir Lang organization on GitHub. And it sort of sets up like all the necessary things, so that your C source is compiled before your application runs. So then there's this, everybody's probably seen this, Erlang, keep calm, let it crash. Unless you're writing a NIF. So yeah, maybe we try this in Rust. You really have to be careful with NIFs. I mean, there are always trade-offs, right? Maybe it's not important that your application is always up, maybe a crash is acceptable under certain circumstances. For example, if it's like some sort of terminal application. But if we do want to try to get more safety guarantees, we can try to write this in Rust. There's a cool project called Rustler, which allows you to sort of write NIFs in Rust. And then you get additional guarantees. The setup in Elixir is similar. You're defining a module, and this is sort of a wrapper module. And when the dynamically loaded library is then loaded using the module hooks, it replaces this wrapper implementation. You can see there's a macro here, with use Rustler, OTP app, and all that. But in the end, it is actually calling the same onload and using the same load NIF function from Erlang. And then the actual implementation for the Rust code, it's very similar. Here we're also defining the module name and the function and its arity, and then a reference to the Rust implementation. And here we are just offered a little extra safety. In practice, like I ran into some bugs with the Rustler implementation. I think it's not totally safe yet. I think it's a very cool project though. A final strategy for implementing interoperability in the Erlang ecosystem is C nodes. And the idea here is that you're implementing another Erlang node or something, or sort of a lookalike, right? It's able to communicate with the other Erlang nodes, but it happens to be implemented in C in this case. And the Erlang interface also provides the required functionality for this. But it is a lot of effort to implement something like that. So here's this chart again. You can kind of see like the different trade-offs, the different heuristics. So NIFs have the example or have the advantage of low latency, right? Because it's directly within the VM. It's also not so complex, right? Because you're defining a short C file that just replaces the Elixir implementation at runtime. But it has disadvantages, of course, that you have no isolation, and any sort of crash will crash the entire VM. So it's probably not a good idea for your web app if you want it to keep running. I actually have been experimenting with NIFs a lot. I was on vacation, but I stayed in Berlin, so I was playing around a lot with Elixir. And one of my challenges here at Cochner.io is we have sort of a Docker-based setup. We're running containers within Google Cloud on the Rancher container orchestration software. And I want to be able to monitor the Elixir, the Erlang nodes, and see how much memory is being used and which processes are running. Maybe certain processes have died. So I've been looking at ways to do this. And my thought was, maybe I'll implement an HTOP for observer. This is sort of like a terminal application, and it would be similar to HTOP, provide you the same sort of information you get in the observer app, which is here below, by the way. It's a really awesome application, but connecting it to a remotely deployed Erlang node isn't always easy, especially in the context of Docker, where you have complicated port configurations. So I set out to kind of try to implement this HTOP, and then I looked at Termbox. Termbox is a really nice API for building terminal UIs. You have basically 12 functions that represent the entire API. You can start the thing up, shut it down, get the windows width and height. You can set certain cells, contents, and then also do event handling, of course. So I've been building an Elixir wrapper for this that implements it with NIFs. And in this case, I sort of determined that I was willing to accept the trade-offs of NIFs because this is an application running on my local machine, and it's okay if it dies. And even in production, I think I would run it on a separate Erlang node. But it would re-implement the same API with some Elixir helpers on top. The idea is kind of to have low-level termbox bindings and the constants there, and then provide a high-level functional interface. If you look at how a lot of the ncurses-based applications work, it's really ugly. They're in all sorts of for loops and changing cells, and it's in a totally stateful manner. And I'd like to do this in a functional manner with sort of an XML JSON-like structure. It's actually just a tree implemented in Elixir. I have a view, and then within that are elements. They can have sort of a descriptor and attributes, and then children. And then I can render the entire tree, the entire view tree. I ran into a few scheduling problems with this because you have this event loop. When you're running a terminal application, you want to wait for events, for keyboard events, mouse events, resize events, and you need to handle this somehow. And the way Termbox works is it has this TV poll event, which just waits forever for a keyboard event. And this is really, really problematic for the Erlang schedulers. I have sort of a diagram on the right over here. Typically, the Erlang VM runs in a single operating system process, but then it has a operating system thread for each scheduler. And the schedulers, they then have sort of a run queue, and they can iterate through the different processes. And each process is allocated a certain amount of time to execute its code, after which it's preempted, and then we move on to the next process. And the problem with natively implemented code is that the scheduler is not able to preempt it, right? Because it's running natively on a level deeper. So yeah, I mean, for the scheduler, right? This is what the NIF says to the scheduler. It doesn't have the power to preempt it. This is sort of an example of how you would set this up, right? You have a NIF, and it's going to loop, and it's going to sit here in a loop and sleep for 1,000 seconds and do it again, and it'll never go to that return, of course. And then you have the scheduler test. You want to run a timer loop and print the date time, every 1 second. And the problem is you could spawn this timer loop right in a separate process, and then start this mynifs loop, and the separate process will never get scheduled. So this is a huge problem, right? If you were using a NIF, in a big Erlang application, your processes aren't getting scheduled. Your NIF is stealing all the execution time. So then there's the question of how do you write well-behaved NIFs? There's some guidelines. Your NIF should return very fast, within 1 millisecond ideally, which is very fast, but in Elixir that's actually not so fast. And any longer running work needs to use a different strategy. And there's different approaches here implemented in the port driver interface and also the NIF interface. You can do the work on a different thread, right? You can return early and then let your NIF manage the thread. You can also return a resource object that has a destructor that will then join the thread, when the work is complete or when the resource is garbage collected. You can also split the work into time slices. So you do a little bit of work and then you schedule some more work, and so on until the work is done. Or there's a new feature where you can mark the NIF as dirty, and then this sort of informs the scheduler about its different characteristics, and it knows a little bit more about what to expect. So that's it. Any questions? Yeah.
So on that last slide there, so if you do mark your NIF as dirty, will it now handle the case that you had there properly, where even though the thread is totally consumed, everything's fine and you're not blocking other processes from running, or is that not sufficient for your use case?
It's not really sufficient, no, it's better. But it's also a new technology. I think it's relatively recent in terms of the Erlang release. I haven't used it personally, but I've researched it a little bit. Yeah.
Can you comment on using ports or port drivers for communicating with blocking I/O? So I guess a classic example would be you have a serial port and you're waiting for data and you don't know if it's going to arrive. It might be minutes, right?
Yeah.
So that's possible, right? Because each is each port running in its own thread? Is that, or I know there's some way you can basically tell the VM reserve this many threads for blocking I/O on ports.
Right, and the port driver can also run in a different thread, right? I think ports are a good use case for that because they can be long running and they also won't necessarily take down the Erlang VM. If that answers your question.
So that would be a good use case for it. Okay.
I think so, yeah. If you look at, I think a lot of the embedded software, it seems like they tend to use ports when possible because they're safer.
Right.
Yeah.
Was it Rustler, the name of the
Rustler, yeah.
So you mentioned that you encountered some bugs when you tried to use it. What kind of bugs were they, and did you try to report them? If you did, what was the community around that library like?
I just recently looked at that actually, but I ran into some different compilation issues on my Mac. On Linux it was fine. So I saw there was already an issue on GitHub about that. In general, I saw other issues on GitHub about segfaults. Which of course is what you want to try to avoid with Rust, right? But I think it's still a relatively young library. But it was a cool experience actually using Rustler, right? It can generate sort of a lot of the boilerplate for your NIF, and then you kind of fill in the blanks. And you can use Cargo to build it.
Did you look at the implementation of Rustler at all on the Rust side?
A little bit, yeah. And it's similar the way a lot of this stuff works. They're defining types for the different Erlang terms, symbols and atoms and whatnot. Any other questions? All right.
So if you everyone for coming and Bob and I for hosting us. I guess now we can have still like finish the pizza and have some beers and have some interesting discussions, hopefully, until the people, the hosts will kick us out.
If I may, one last thing, Tucker, I will be present in Warsaw this year at MixerCon. We hope to see you there, and we'll be here a while. So.
Yes, so take some home and drink beer. We have too much beer.
So it's a great.
In the fridge.
Developers will drink it tomorrow.
Yeah, I forgot to demo it. I wanted to demo it actually.